Hello everyone, welcome to this session of serverless application with AWS step functions. So today we are going to talk about how to develop serverless applications using step functions. My name is Rajesh Bhojwani and I am a solution architect. I've been working on AWS since last 6 months and I've been playing around with Lambda functions and step functions. So I will be sharing my learning on this topic. So we have been building applications using Lambda functions for a while. But what I found is that there are many use cases which are still difficult to be implemented using Lambda function. The reason being is that Lambda comes up with a lot of limitations as well. I've written a blog around it and even the video also. You can go and watch about it, where I talked about what all the limitation it has and what all the best practices are around Lambda function. So come to this topic. If you want to develop applications where you have sequence of events or sequence of tasks to implement, you can do that using Lambda function. But if you need to orchestrate all those steps or the tasks, then it is a tedious job. And that's the reason it's not easy to do that with plain vanilla Lambda implementation. If we talk about the another use cases, let's suppose you want to run the task in parallel and then you want to use the outcome of those parallel tasks to fill into the another task and then execute it. That is something also is very difficult if you don't have any orchestration system around it which can collaborate all the inputs and output and coordinate it with all those tasks. So let's assume that we are running a sequence of tasks or parallel task in Lambda or any other activity worker. What if those tasks started failing? Maybe it is a temporary reason that the downstream system is not ready or some system network glitch. Most of the cases can be resolved by just retrying that call to the third party service or to the downstream service. And that's the way you would need the retry feature, which is right now missing in Lambda. You have to do it by your own. Now let's take another scenario where you execute a task and based on the output of that execution, you want to take action A or action B depending on the data value. That is something is not available as a built-in feature as of now in Lambda function. Now let's talk about one of the most common scenario where people started using Lambda function is for the batch job. Now we know that Lambda has a maximum execution time allowed is 15 minutes. So if you have a batch job which needs to run more than 15 minutes, then you cannot do with the Lambda. And the kind of data we have now in the system, it needs more and more execution time. So that is something we cannot do it in Lambda because of the 15 minutes of limitation. Now what if I want to do the error handling in my functions? If I want to put try, catch and finally block, handle the exception and then pass that error to the next step, how do I do it? There's no feature right now available in Lambda for handling that stuff. And that's the reason we need the solution around all those scenarios. Some of the possible solution would be like the first one is function chaining, which I sort of talk about it while telling you the limitations of lambda function. That if you want to use this sequence of tasks to do, then you have to do function chaining, calling one lambda function from another lambda function. But suppose some of the lambda function gets failed, the chain is broken, then how do we handle it? That solution is not available right now. The second option we have is to orchestrate tasks functions using the persistent storage like RDBMS database. Now, what we can do is that the lambda function, which are generally stateless, and they can store the output of each function on the database, and the another function can read from there and then execute its steps. But the problem with this solution is that the RDBMS DBs are not generally scalable. So it's very difficult to scale your application while using this solution. One more solution which resolves the scalability issue is by using the queues. The one lambda function can put the messages into the queue, another can read from there. But again, the same challenge will still be there, that there is no orchestration readily available. So we have to build the error handling mechanism. We have to do retry logic, and we need to find a easy way to pass the output of one lambda function to another one. If you want to do filtering of those output data, then it is very difficult. I'm not saying it is not doable, but it will be tedious and it will be difficult to maintain those kind of logic in this solution. So far we understood that when we build a application which have the several functions, several tasks to be implemented, and they need to talk to each other, then there are few things which are must to have. The first one is that at each task level there should be error handling available, where I can catch the exception, handle it. Then I should have a retry mechanism for certain type of errors. I should be able to retry calling again that function and put the limits also in that. So we should have a flexible retry logic available in that. And then the third thing would be that we should be able to pass the output of one function to the another one, and we should be able to filter those inputs. That is what we would be needing most. Now, when we have multiple steps running, multiple functions running for your workflow application, then monitoring becomes a important task, because we need to know at what step what function is failing, due to what reason, and that is required for debugging. Another important thing is that maintaining the state, because most the serverless functions, the lambda functions are stateless. They don't maintain the state, and while passing the data from one function to another function, you need to maintain the state of those. So these are the main important things are required for a solution to get the orchestration of multiple tasks and the functions. So here we have the AWS step functions, which helps us to address all these challenges and overcome them. So I will go with the AWS definition, which says that it makes it easy to coordinate the components of distributed applications using workflow. So not only it helps us to do the coordination of multiple tasks, it helps us to visualize that flow what has been designed. So in step functions, what we do is that we write state machine flow using the JSON, and then it equivalently creates a diagram which shows the end-to-end flow, where you can see how your workflow will be running from start to end. I've been talking much about through PPT. Now let's go to the AWS console and then see how exactly the step function works. So before we go to AWS console and look at the real application, how step function works, let's try to first understand some basic jargons or basic terminologies around a step function. So what I will do is I will open a blog written by me on the AWS step function and first try to understand what basically the step functions are. So in step function, what we do is we create a state machine. So this state machine is nothing but you design your task, your application workflow with multiple states, and task is one of the type of states. So we basically will be having 6 type of states. Let me just show you quickly what all these states are there. So the task state is something which is the main state which actually does all the work. So in the task state, you will be able to configure to point to your Lambda function or your ECS task, or if you have created any activity worker, that also you can point it through that. The second one is the choice state. So we talked about it that this is one of the requirement when you want to call one lambda function or the another based on the data which we get. So that's the way this choice state helps us to do that. The third one is about fail and succeed state. So when our job gets failed, we can define what needs to be done on the fail and the success. So the pass state is mostly used to just pass the output of one state to another uh, and injects the data to some other lambda function. So that is what it is used for. Now wait state is all about if you want to put some delay on your lambda function execution after the first one gets executed. Last one is about parallel state. So this basically helps us to branch out the execution in multiple directions. So this helps us to run the lambda jobs in parallel. And these are all the states which we have in state machine. Now when we run any state machine, when we execute it, we need to pass the inputs, right? So state machine accepts JSON as the input data. Now when we pass this input data and then we run the task logic in our lambda function, then the output is generated which will be going out of that state and either being passed out to another state or you end it with that output. But before you get the output, it will go through several filters. So we have 3 filters. First one is input path, second is result path, and third one is output path. So when we pass input while running execution, what this input part does is it takes the whole JSON and then filters it. So let me try to explain that with a simple example. Let's suppose I have a JSON input which I am passing to my state machine to execute, and I have this state definition defined which will be processing this input. Now here if you notice that I have put three attributes: input path, result path and output path. So using these filters I will be filtering the JSON input. Now notice that in input path I have put $.lambda. If I am passing this whole JSON object, if I take the $.lambda, then it will be taking only the lambda node of this input and then using it for the state to execute. So my first state will be taking only this node for processing. In result path, if you notice that I have put $.result.lambda result. So what does result path does is execute the state using this input, and whatever the output is generated will be appending that to the dollar. So dollar means the whole in JSON object which we received in the state machine. In that the result node, and under which I have total node. So in the result node I will be adding a total node which will have the output of that state execution. So if you see here, I got added this total attribute which is the total of these two subject numbers. The next attribute what we have is the output path. So in output path, what I have put it as a $.result. So even though I have the whole JSON object dollar being tagged as a dollar, it will be passing it as a output. But just because I have used the $.result in the output path, it will be taking only the result node of that JSON object, and that will be our final output from that state we will be getting, not the whole JSON object. So I believe this is clear, the input and output processing, how it works. We talked about uh, the states, we talked about the input and output processing. Now let's go back to the AWS console and then see how do we develop a step function in AWS. So if you come to this state machines, it will list down all your existing state machines, and whoa, but for this case what we'll do is we'll create a new state machine so that I can show you how does it work. So when you open a state machine, it will give you three options. The first one is author with code snippet. So in this what we do is we just give the name of the machine. Let's suppose I give a name as first machine. Here you have to put the code, and whenever you put the code here, you will see that in the right side it will create a graphical representation of your state machine. Okay, a step functions work with many AWS services, not only with Lambda. Let's suppose you want to write a ECS task, right? So what you can do is you click on this, and then this will generate a preview of that code, and then you can copy that code into the clipboard, and you can paste it here and then use it like this. Okay, it will resolve some of the issues which it generates. So this is very user friendly, where it tells you even the coding errors, coding issues. So in this case I just created the new state, right, manage ECS task, but I'm trying to refer the hello world to start with, but there's no uh, hello world state defined here, so I have to change the state with this name, then it will fix that error. So similarly it will tell you all the issues and you can fix those. If you let me fix it quickly, this one, and then we'll see the state representation is coming. So see, once I change this, it has changed the diagram also, the flow also. Okay, so that's the way you can generate your state machine by using this code. Just remember that the basic syntax will be that it needs to know from where to start. So you have to give the state name here, and then you have the state node where you'll be defining what will be your state name, what type of a state it is. So we will be using the task state to do all our functions, our actual code execution, and then resource will be having the ARN value, which resource you want to use it. So for that ARN you have to mention it here, and this is based on each services what you use, different parameters, different execution different parameters, different configuration you have to do it for those. Okay, let's look at quickly the other option we have. So here AWS has provided already couple of projects readily available which you can use. So if you look at a batch job, right, so if we select that, it will provide us the readily available code which you can use to configure your batch job. What here you have to just do it, that changing your uh, batch job configuration, give the resources for that. You have to give the queue name of that, define, put the ARN for that job, what you have done in AWS batch. So once you make all these changes, your state machine will be ready to execute. Okay, if we quickly see that how we pass from one state to another, we will have this next attribute which tell us once this state gets executed, which next state we have to go to. And if you want to do any exception handling, error handling, then you have to define this catch block, and then you can define if you get this type of error, then what I need to do. Okay, let's look at the third option, which is templates. So in templates also you will get many ways templates actually available, which will help you actually to implement those different type of states. So we talked about that we have a wait state, we have a try which we can use it, we have the parallel state which we can use, and then you have catch and choice. So if you look at this choice state, let's quickly go to the choice state and then see what it provides. So if I select this, it will give me the readily available code which explain me how the choice works. Okay, this is the option we have. So here if we just fix the ARN of that resource for the lambda function, it will start working. Okay, uh, so that's all about how the state machine works. So let's quickly go and then look at my existing state machine division number which I created it, and state machine we can see there's a audit log that how many execution has been done for this and how it is working, right. The one important thing you need to remember is that whenever there is a execution happens for any state machine, there should be a unique name on that. Okay, so when we click on this start execution, you should give a name which should be unique, and it should be unique for your whole account for at least for the 90 days. So if you used a name 90 days back, that you can again use it, but not before that. Okay, so if I don't give a name here, then AWS will create the unique name by itself. So the best practice is that you can leave it blank so that let AWS find it out what is the unique name for you, and then it will do the job. So let me give a input to this execution and then run it. So if you remember, if you can see that it has created this unique number for that name of the execution, and it will start doing the execution. So if you see in this visual workflow in the left side, we have different states: success, failed, cancel, and in progress, right. So now it is green, it has been successfully done, but if you would have noticed it earlier, it was showing blue when it was in progress. And in the right side we can see for the each step what is happening there. So if we click on this diagram for that particular state, then I can see if that state got succeeded or failed or it is in progress. You can see those status. Then we can see what was the input being passed to that state and what was the output being generated of that. Okay, if that state get fails, then you will see the exception also in this block. So that's the way you can monitor your state machine, what is happening. This is the one way of monitoring. The another way of monitoring is that you will see the execution event history here. So when I ran this state machine, it has created 14 execution event history steps. So if I click on this, it will tell me that this is the where execution started with this input. Okay, and then you can see it will go to the each state. So now I am in the first state. When I go to the first state, what is the input has gone there, it will show me that. Now once I get out of that state, so this state got exited here, and it will show me what is the output came from that state. So for each state you can go and then check what is happening there, what is the condition, what is the input and output is coming. So that's the way step function works. We have seen that how you can monitor the logs, how the auditing is done. Now we are going to talk about what are the benefits the state function is providing, what are the limitation it has, and what are the best practices are there to handle those. So let me quickly talk about what are the benefits are there. So first we talk about the retry feature. So we uh, talked about it that every orchestration needs to have this feature. If a state is getting failed, it should be able to retry that. Now if you notice here, when you retry, it gives us these three parameters. Interval second is the interval between the two retry. Every 3 seconds it will be trying it, and maximum attempts will be the 2. It will error out after the 2 attempts. And then the third attribute is about back after. It will increase the interval time between the two retry. The first retry will be after 3 seconds, and the second retry will be 3 plus 1.4, which is 4.5 seconds for the retry. So that's the way retry feature works here, and it helps us to resolve many intermittent issues. Error handling is one of the best benefit it has, because none of other solution will have readily available how to do error handling. It handles the timeout error. You can catch that error and then decide what to do. It can handle the task failure error. It can even also handle the permission error. If none of these errors get caught, if there is a different error, then it will fall into this states.all option. So when you compare your error equals, so you have to compare with these all error types, and based on that you can do error handling. So it's similar to what you do in Java, where you check your exception if it is a index out of bound exception or any other exception. So you do error handling based on these exception types. You can look at this example how it does it. So you catch this error, you compare these exception types, and then you decide which state you want to go for from there. The next benefit about step function is parallelization. So as we discussed that it can spin up the multiple states running together and doing the job in parallel. It step function also has a high execution time, right? So it can run for more maximum 1 year of time. So if you have any batch job or any workflow which is more than 15 minutes, then step function is the best option for you. The pricing part, step functions being charged based on the number of transition you do from one state to another. And if you look at those charges, it looks pretty high on the face, but if you come up with your own solution of doing the orchestration between the states, this will be this will look to you much cheaper than those solutions. Okay, but you have to keep watching your builds through logging and monitoring to ensure that it's not burning your pocket. Now let's talk about some of the limitation what I have identified in step function. The first one is about shorter execution history. You can keep your execution history only up to 90 days. So I showed you that one of the step function when you execute it, it was generating the 14 events in the history logs. So these logs will be available only for 90 days. So if you have the retention period which is more than this, then it cannot be done. It's a hard limit. I found it that there are some triggers missing in the step function. So right now the step function can be triggered through API gateway, through SQS, or through CloudWatch events. But DynamoDB or Kinesis, those kind of event sources are missing, which are available in Lambda. The next one is state machine execution name. So we already talked about it that it has to be unique at least for 90 days and not used in last 90 days. Step functions does not horizontally scale to dynamic launch AWS Lambda functions. So let's take an example. If I have a Lambda function which is generating 10 messages, and then those 10 messages needs to be run in the parallel by the next lambda function. But this lambda function cannot be dynamically scale out. It's all statically defined. So it will assign only the same number of the task executor for that. It will not dynamically do concurrent execution of those lambda function. The one more limitation I found, which is not documented here, is if I'm running a step function execution and it fails on the step number 3, let's suppose. Now next time I execute that, I want to start from the step 3 rather than starting from the beginning. That is something is still missing in step functions. So these are the limitation I found it based on my experience. Now let's talk about some of the best practices. The first one is that which we just talked about the limitation. There is a workaround of implementing restart your state machine from that particular point from where it got failed. And how you can do is it has been documented by AWS by their blog. So I will suggest you to go through this blog and it will help you to understand how you can do that. Um, at the high level, what this blog talks about is that you need to identify the failed state of your execution by calling some of the APIs which it provides, and once you find it out, then you have to create a new state machine which will be triggering and starting that state machine from that point. The second point is about the state machine maximum execution time limit. So as I talked about that it is 1 year up to the which you can run your state machine. So if you miss to define your timeout seconds in your state machine, then it is going to cost you very much if for some reason your state is stuck for any of the responses. And on top of that, it provides you another feature called continue as a new execution, which can spin up another state execution from your existing running execution, and that is going to make your execution to be running infinitely. So be aware of this issue, and best way to identify those kind of issues is through monitoring your execution metrics and defining your timeout limits for each execution. The third one is about the event history, which we talked about, that there's a 25,000 limit is there. But if you use the feature of continuous new execution, then you can overcome this limit and you can spin up multiple state execution for your state machine flow workflow, and you can distribute your event history with those state machines, right? So let's suppose if you have a long running execution which has 10 steps and you are expecting that it will have more than 40,000 state event entries, then you after the step 5 you can spin up the another execution and distribute those event history between those two execution. The next one is about timeouts. So by default, Lambda function does not set any timeout for your state execution. And as we discussed, if you have any problem with the response of another state, it will be keep running it, right? So you should be defining your timeout seconds in this, and then also you should be defining your heartbeat seconds as well. So what is the use of heartbeat second is that if you have a long running task, if you have an activity worker which is not in AWS, it is running outside of your AWS, then you need to define this heartbeat seconds to keep that thread alive. The way it works is that your worker needs to make a call to the state machine within this heartbeat second of time, call using the send task heartbeat API call, and call it periodically to ensure that your thread is alive. And that's the way you can run your long running tasks. One piece of advice is don't use the step functions for your live API calls through the API gateway, because REST API calls are meant to be very short, which can execute within few seconds, and for that step function is not the good answer. You can directly implement the lambda function to do that job and get it running. Second thing you need to remember is that API gateway makes a call to the state machine in a asynchronous way. Okay, so it's fire and forget. It does not give the response back. If you need to get the response back, there is a API called describe execution. You need to poll to this API using this API periodically to check if the state is still running or it got completed. Once it got completed, then you will be able to get the response from that. So you need to always write a second method to do that other than your actual method which is running that state machine execution. So it's a bit complicated with API gateway. I believe that in future AWS will make it little simpler to run. Now let's talk about how to do logging and monitoring of a state function. I have kind of showed you how we do logging and monitoring, but let's have a quick look on this. So with CloudWatch, you can do the monitoring of all the logs for the step function similar to the Lambda, what we do. It provides many matrices like execution matrices, activity matrices, Lambda matrices, and if you see in this snapshot, it shows all those execution type of matrices available. You can just click on this and go find it out. The another way of doing the monitoring is checking the visual workflow, which we walked through just few minutes back. The third one is about the event history and that how for each step it logs what is the input, output, and exception. So these are the ways you can do monitoring. It also provides the integration with CloudTrail to log the events. How you can use that to build the complex workflows, passing uh, data from one state to another state. It provides the out of the box features like error handling, retry, visualization panels, So use those features and see how it works for your use cases. But as I said that it might not fit all the use cases. Be aware of the limitations and use it as per your use case. Thank you for listening me. You can follow me on Twitter as well as you can go to my website www.rajeshbhojwani.co.in. I have several blogs around AWS, cloud native applications, PCF, and so on. If you have any comments or any feedback, please put it in the comment section. That's all. Thank you.